All right, greetings. In today's lesson, we're going to look at integration by parts, the tabular method. Now, the tabular method is a particular method which allows us to do some integration by part problems a little bit quicker, gets to the answer in a more straightforward fashion. This is particularly the type of integration by parts problems where you have to do integration by parts, multiple times. So we'll look at an example and we'll do it the old way, and then we'll look at the tabular method and let you compare the two methods. So let's go ahead and get right into it.
Specialized in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.
All right, so I have a problem that I would like to do. So let's say we're going to integrate x squared times e to the power of negative 3x dx. All right, so it's a typical integration by parts problem. Again, when you look at a problem, try to dissect the diagnose to see what you should do. You should go through all the first thing. First thing I always look at is use substitution, and use substitution can be done in a lot of clever ways. And use substitution is not going to work on this. And just look at it, kind of fits all the criteria for a typical integration by parts problem. So we're going to do it in traditional methods. So we have to think about the integration by parts formula. Now, sometimes people get confused. Am I integrating u dv or v du? That's a pretty easy thing to remember if you just remember the process. If you've done the process enough, the first thing you do is select the value for u, and the second thing you do is select the value for dv. And so obviously you're integrating u dv because those are the two items that you're selecting. Now, if you ever get confused about the actual formula, think about ultraviolet voodoo.
What?
Yeah, I said it. Somebody had to say it. Yeah. Ultraviolet voodoo. What do I mean? Ultraviolet voodoo, my guy. But just remember that minus sign, and that's your particular formula there. So again, what we'll do is we'll take values for u and dv, and then we'll differentiate u to get du, and we'll integrate dv to get v. And so typically, people have these different acronyms and the different things to think about when selecting the value for u. The more problems you do, the more you'll know what the correct thing to choose for u. But typically just general guidelines, and I really just believe in just giving general guidelines versus a little checklist acronym to go by. U is typically something in most cases that if you differentiate it, it's going to become a simpler function. Now, of course, there are other occasions where, the value for u you take stays the same. It doesn't get simpler or complex. It kind of stays the same. But in general, it's something where if you differentiate it, it's going to become simpler. And so I'm going to make u equal x squared, which leaves dv to be e to the power of negative 3x dx. And so if u is x squared, then du is 2x. And if dv is e to the negative 3x dx, then v is negative 1/3 e to the negative 3x. All right. So I have my u and my v, and I have my v and my du. So then the integral, let me use another sheet of paper. Well, let me just move this up so this can be seen. So then the integral of x squared e to the negative 3x dx is u times v. So that's negative 1/3 x squared e to the negative 3x minus the integral of v du. So v is negative, so that'll become positive. And there's a 1/3 there. We can put that 1/3 in front. And so minus, actually there's a 2 there from 2x. So let's put a 2/3 in front. And so minus the integral of v du. So again, that minus made it plus 2/3 x e to the negative 3x dx. All right, so you can see we've done integration by parts once, and the guy in the integral can't be integrated at this moment. So that means we're going to have to do integration by parts again to be able to integrate this guy. And so this is why this is some of the more longer problems, because you have to do the process, in this case, twice. And basically when U is a polynomial function, you have to integrate as many times as its power. So as many times as it takes for it to break down into a constant. So let me just rewrite this statement and then continue the integration by parts journey here. So in fact, let me rewrite the complete statement. So what I have thus far is the integral of x squared e to the negative 3x dx is equal to negative 1/3 x squared e to the negative 3x plus 2/3 times the integral of x times e to the negative 3x dx. All right, so again, right here, we're gonna have to do integration by parts again. And when doing integration by parts multiple times, in a lot of cases, there's gonna be some coefficient here. And just remember, whatever you get from this result, that whole thing is being multiplied by this coefficient. And so for just a second, I'm just gonna concentrate on just this part here. And I'm gonna say that U is gonna be X, and then dV is gonna be e to the negative 3x dx. So du is dx, and that's what we're looking for. And v again is negative 1/3 e to the negative 3x. So, and what I'll do right now is I'll just write the integral of just x to the e negative 3x, and then I'll multiply by 2/3, and then I'll bring everything into the process, if that makes sense. So the integral of x e to the negative 3x dx would be u times v, so that's going to be negative 1/3 x e to the negative 3x minus the integral of v du, so v is negative, so plus, and I'll take this out, plus 1/3 times the integral of e to the power of negative 3x dx. And now this is something that we can integrate. And so the integral of e to the negative 3x, of course, and we've done it several times already, a couple times already, it's negative 1/3 e to the negative 3x. So this is going to be negative 1/3 x e to the negative 3x. Plus, well, it's going to turn negative because that's going to be negative, minus 1/9 e to the negative 3x. And there's a plus c that I'll do at the very end. And again, this is the integral of x e to the negative 3x dx. And so what I want, to complete this process, I want this guy times 2/3. So I'm going to multiply everything here by 2/3. I'm running out of a little space. Well, I'm running out of space, so let me move this guy up just a tad. And hopefully it's still visible there. So this is the integral of x e to the negative 3x. And so what I want is 2/3 times the integral of x e to the negative 3x dx. And so that would be negative 2/9 x e to the negative 3x minus 2/27 e to the negative 3x. All right. So this is the integral of 2/3 x times e to the negative 3x dx. And again, well, you can't see. So this is this. So to that, we're just going to add that, and that's going to be our answer. So I'm just going to put in the front of what I have thus far, a negative 1/3 x squared e to the negative 3x. And so let me write, and this is the final answer. So this represents the integral of x squared e to the negative 3x dx. And again, I'm just going to write what I have right here. And so again, that's negative 1/3 x squared e to the negative 3x. Negative 1/3 x squared e to the negative 3x. And then it's just this junk here, minus 2/9 x times e to the negative 3x minus 2/27 e to the negative 3x plus some constant. All right, so that is the answer to this integral. As you can see, it was a little bit of work. It was enjoyable work, but it was work nonetheless. So I'm going to do this same problem by this procedure I'm talking about called the tabular method. And I'm going to explain a little bit. Really, I'm just showing you a procedure. It's really a procedure to go through, a way of doing it. But it doesn't work at all on all integration by parts problems. So we'll talk a little bit on the type of problems that you can use it on. Of course, this is a type of problem you can use it on. So we'll go ahead and do this guy by the tabular method. And you can see we've been going on for, about 10 minutes or so. And at that 10 minutes, maybe 7 to 8 minutes, we're actually doing this problem. And you'll see in a second by the tabular method, we're going to do it in a lot quicker time. We're going to get a more direct result. So let's go ahead and introduce the tabular method. So let me just rewrite the original problem. So the original problem, we're integrating x squared times e to the negative 3x dx. All right. So I'm going to make a little makeshift table here. And one column I'm going to have a sign. And the next column I'm going to have u. And the next column I'm going to have dv. So pretty much the same stuff as before as your u and your dv. This guy is new, but we'll kind of look at what happens. And so you still want to think about the appropriate functions to choose to select for u and dv as before. And so we already know our u is going to be x squared and our dv is going to be e to the power of negative 3x. And the sign is going to start off as a plus sign, and the sign is just going to alternate each line. Now, what we're going to do here is we're going to differentiate this guy until we get 0. So we want to take the derivative of the u term until we get 0. And then we're going to integrate this guy until it gets to that same line, the line where the u term became 0. And so if that's the process, then to be able to use this method, our u has to be something that if I differentiate it multiple times, I'm going to get 0. So our u has to be a polynomial term, because that's the only way we can differentiate multiple times and get 0. So typically for these problems, to be able to use this particular method, your u needs to be some polynomial term that differentiates and becomes a constant of 0. So, it needs to be a polynomial term with positive exponents. All right, so I'm going to take this derivative until I get 0 in successive rows. These signs are just going to alternate, and I'm here just going to keep integrating here until I match the line that gives me 0. So let's see, the derivative of x squared is 2x. The derivative of 2x is 2, and the derivative of 2 is 0. There I can stop, and I'm going to alternate these, minus, plus, minus, and now I'm going to integrate negative 1/3 e to the negative 3x, positive 1/9 e to the negative 3x, negative 1/27 e to the negative 3x. And you might see some, similar things that we saw when we were going through the process, the first method. Now, what do? Well, we take this plus sign and we go to this guy, and from this guy, we go to this guy. And that gives us our first part of our answer. So you see it's negative. Our first part is the product of these two, which will be negative 1/3 x squared e to the negative 3x. And that should make sense because when you're doing the process starts off u times v, and this obviously is u, and the first integral of this is obviously v. So that makes sense. And now you also know when you do the formula, there's a minus sign times the integral of v du. And so that's kind of where this comes from. So we're going to take this minus sign, and again, we're going to follow from this guy to this guy. And again, we're just going to multiply. And bear in mind, we have a minus sign. So since both these are positive, this guy is going to end up being negative. And this is going to be 2 over 9 x e to the power of negative 3x. And then we'll continue again, and notice we're on the last line where we have that constant. And so we're going to follow and multiply as so. And you can really see this sign here, this negative sign, is not even going to be used in the problem, nor is the 0, of course. But you do have to take the derivative till you get to 0 because you need to know where to stop integrating that. And so in order to get this term, I did need to differentiate until I got 0. Didn't really have to put the minus sign there, but I like to keep everything level. So even though I'm not going to use it, I wanted to put it there anyway. And so again, this is positive, but this guy is negative. So if we multiply, we'll get negative 2 over 27 minus 2 over 27 e to the power of negative 3x plus c. So that's the exact same answer we just got by the other method. Even notice we got there a lot quicker. So that is integration by parts by the tabular method. Again, in order to use the tabular method, you need a value for u or a function for u where it's a polynomial with a positive coefficient. So you can differentiate it until you get 0. So again, that's a quicker way of doing some of the integration by parts problems that could, be very involved and detailed. Hopefully you find this useful in your calculus pursuits. We'll see you next time.
First you separate, and then you integrate. Just follow these steps, and you will do great. First you separate, and then you integrate. Just follow these steps, and you will do great. First you separate, and then you integrate. Just follow these steps, and you will do great.
Tis the season to be serving.
When I was solving equations, I was feeling amazing. Problem after problem until the day's end. Solving, keep solving, and turn the page in, and still keep grinding. Solutions keep finding. I have never seen a problem like this, but I know exactly where it fits. First order, separable, ODEs. Now I know what to do, holy me. First you separate, and then you integrate. Just follow these steps, and you will do great. First you separate, and then you integrate. Just follow these steps, and you will do great. First you separate, and then you integrate. Just follow these steps, and you will do great.
Kind of a mathematical outlaw.